going to start lining up the Math 109 with the Math 110 class on the videos, because basically you're getting double, and I'm also going to do it with the 109 with the 110. So when you go to the 110 videos for the 1 or 2 people that actually use the videos, you're going to see double. You're going to see a Math 110, and then you're going to see a Math 109. And the reason that is we're covering the same what? Material. And, you know, it might help you to have different problems, but it's going to be covering the same material. Chapter 6 in Math 110 and Chapter 5 in Math 109 is all about inverse functions and logarithms. And in order for you to, Pendleton, y'all copying this down?
Yes, sir.
Okay, because you don't look like you're writing or anything. That's why I was wondering.
I can't see your whiteboard.
I'm sorry. That's why. Pendleton, you should have said something. Pendleton just sits there, don't say a word.
I was just listening to you.
Oh, okay. You were paying attention. Is that what it was?
I was.
Yeah, okay. All right, there you go. So make sure you take a picture of this. We got a couple of questions to go over. I think a couple of online students sent a couple of questions, and I want to cover those, and then we're going to move on. But I want to write these down because the left side is the exponential rules. Should you already know those? Yes. You should see those and go, oh yeah, I remember. You add the exponents, you subtract the exponents, you write a negative exponent as a positive exponent, fractional. So you should know, and I'm going to write down, I'm going to highlight the ones you should know and the ones that are important, okay? On the exponential laws, you have the product rule. That one's important. Did y'all not see me? Did I not hit the highlighter button?
You did.
I thought I did. Okay. There's the product rule where you add the exponents. The quotient rule where you subtract the exponents. The power rule, which is basically the distributive law with exponents. Don't use that one very much, but you can use it. That means that you distribute the power with both the terms inside the parentheses. You see this a lot with this. 2x quantity squared. What's the answer to 2x quantity squared?
4x.
4x squared, because you've got to do there and there. And what is the most common mistake students make?
4x.
They get 2x squared. They only do the square with the x. And that's what that rule says. That basically you've got to remember to do it with both. So you use it, but it's not detrimental. This one, you can distribute with that's the same thing as this one. These two are the same. Negative exponent. That's another one that and this one right here. So you've got several that you should know pretty well. Now mark those down because those are the ones that you need to know, right off the top of your head. Now, as far as the logarithms, I don't know how much of you have had logarithms before, so I will be starting with the logarithms from a basement level, and I'll be building up. But as far as the ones that are mechanical, this one is the most important one. This one is called the definition of a logarithm. And as I told you the other day, that one is going to be used in a couple of units. All right? So you need to know that one, a couple of sections in this chapter. These are all numerical, okay, meaning that if the base and the number is the same, that it's equal to 1. The logarithm of any base logarithm of 1 is what? 0. And then you have several of these. If your base and the log and the exponent base is the same, then your answer is P. These are just kind of properties And then you get into these. This is the power rule. This is the product rule. This is the quotient rule, which are basically derivatives from what? Your exponentials. Okay? Now, how do these have anything to do with each other? Well, an exponent, a glorified exponent, is called a logarithm. A redneck logarithm is called an exponent. So basically, they go back and forth. And right here, the definition of a logarithm shows you how. The definition of a logarithm is the transition between a logarithm to a what? To an exponent. And from an exponent to a what? Logarithm. So that's why the definition of a logarithm is so important. All of these, this is the one, if you don't memorize this one, you're going to suck at it. All right? So if you don't memorize that first one right there, you're pretty much going to suck at the rest of it. Now, this is what we're going to learn. I'm going to put it back on the board in just a minute. I'm going to go do those 2 questions that we've got. And remind me, I know the test shuts off when? Tonight?
Yes.
What about the homework?
That was Monday.
Huh?
That was Monday.
Okay, well, they sent the questions. I'm going to go over them anyway because I don't know why they evidently the online. They must have sent them Monday. Or when was it due? Monday?
Yeah.
Then they must have sent it Monday then. I'll just look at them and go over them right quick. I'm sorry, what?
They must have sent it Monday night, 10 minutes before.
Well, yeah. So let's look at it and see. Okay, Math 110, 5.1. They sent one Monday and one Wednesday, so evidently I cut theirs off Wednesday. So let me do, so it cuts off tonight for them. So question 11. Question 11 on 5 point whatever, 1. It says explain how the graph blah, blah, blah can be obtained. Okay, first of all, just ignore the directions. Let's sketch this out. So make sure you can sketch it out. Let me turn this on and turn this on. So we know that the parent graph is going to be either a vortex or a what? Or a volcano. So let's look and see which one it is. Let's go ahead and rewrite this. First of all, this needs to be rewritten. F of x is equal to negative 13 times what? 1 over x squared. Okay? Now you could rewrite it like this. F of x is equal to negative 13 times 1 over x squared, hold on. Hey, my thing just disappeared, so I guess I just supposed to. Love when it just disappears like that and I can't do anything about it. So I guess I just there. Thank you. I appreciate you showing back up. Thank you. Anyway, F of X, Ukrainians, and Tulsi Gabbard and Jill Stein and who else did she say was Russian? Everybody. X plus 0, quantity squared, plus 0. So what is my vertical and horizontal shift? 0. So that means it's going to be going around the what? The origin. So I go ahead and draw.
And it's going to be
a vortex or a funnel because this means it's going what? Down. So that means it's going to be a vortex or a funnel. Funnel. I don't know how to spell funnel. Anyway, and so we know the horizontal shift is 0, the vertical shift is 0 because there's nothing there. So it's going to look like this. Well, let me go back. Where is my whiteboard going? It's not supposed to be doing that. It's supposed to leave a little. Oh. I don't know why it's doing that. See, it's supposed to leave a little box over here, and it's not doing it. Anyway, I'm sorry. Let me go back. There. Okay. The parent graph looks like this. Well, not the parent graph, but the parent graph as far as the negative. Here's the parent graph. The parent graph's up here. But since it's a negative, it's flipped. And what does this 13 mean? It's compressed along the what axis? And it's stretched along the what?
The Y.
Y-axis. So you put in your brain housing group a balloon that is pressed like this means that it's going to be elongated, right? So that means if I press this up like this, it's going to get closer and closer right in here, right? So my finished function, I'll do it in blue since I don't have my finished function is going to look kind of like that, meaning that I'm bringing that in a little bit more. It's going to be pushed in a little bit more. So we know it's not D, because that's what? That's a volcano. That's positive. We know it's not A, so that means it's either B or C. Now, why is it not C? Because that's mostly like the parent graph. See, it's kind of out there. And this one is more what? Compressed. So that is your answer as far as the graph. Now, what else is it going to ask? Well, it says to obtain the graph of F, we're going to stretch vertically. I just said that right here. Okay, that's what they're asking you right here. Okay, and like I said, we've been going over this for how long? 2 units. That first unit we were doing it with quadratics, remember? We were doing it with the parabola. Now we're doing it with everything. Everybody got that one? Okay, I think I've answered pretty much everything. Does it have another part?
As the domain.
Okay, let's go over the domain and range. The domain is negative infinity
0
to 0, and then exclusive, and then from 0 to positive infinity. So that's the domain, and of course it's a union because it doesn't intersect. Intersect would be upside down, it'd be overlap. And then the range is negative infinity to what? 0, but you do not touch 0. So range is negative infinity to 0 exclusively. That's a good test question. If you haven't had the test yet, or you haven't taken the test yet. Is one of those on the test?
Yeah.
Okay. Well, I put so many I can't remember because there's like 5 questions per each question. So I can't remember if it's on there. I know looking at it, I like it because it's short and sweet, and it's not like 15 parts. Maybe 4, but not 15.
Yeah, it's on there.
4 is smaller than
I don't know if it's that exact one, but there's some of those on there.
Okay. Next question. Next question is, I don't know what's wrong with this whiteboard. It's just not, now it's gone. See, it's not. Y'all see what I'm saying? It's not coming up.
That arrow at the very bottom.
Yeah, the arrow at the bottom.
Yeah, but it don't show up.
It don't always show up.
Yeah.
That's what
It's not showing up now. What the heck's the matter with this thing?
Maybe restart the computer.
No, I don't want to restart the computer. There. Okay, let's go back to, all right, that's that. This is that the same one? Which one did I just do? I just did 11, right?
Yeah.
All right.
That's when you save from, like,
You have to go from Monday.
I don't know. Which one do I need to do, 7 or 11?
We already did 7.
We already did 7?
Monday.
Okay, thank you. Yeah, that's the one. I still don't understand that one. But anyway, that one sucks. Okay, so those are the 2 questions, and we're going to move on now. So I'm making sure that there's no more. So let's go to 6.1. Now, 6.1, we're talking about inverse functions. All right, so what is an inverse function? Well, I'm going to show you what an inverse function looks like. An inverse function, as we talked about probably before, you've got a function f of x is equal to x squared. Okay? Algebraically, on the graph, it looks like this. Capiche? All right, so what is the function that is the opposite direction but is still symmetrical? And that would be the inverse function. And the inverse function is, first of all, you say y is equal to x squared. Go back to your redneck ways, drop the pinky, and go back to y is equal to x squared. So you do this first. Second, you interchange the x and the y. So this is going to be x is equal to y what? And then 3, you solve for what? Solve for y. And that's going to be y is equal to the square root of what?
X.
And as soon as you solve for y, that becomes the y inverse. Okay, that's how you do an inverse function. That's how you algebraically find an inverse function. And when you draw this function, it's going to look like, if you could draw it, it would look like this. Well, that's what it'll look like, but you can't draw this. Why? Because you can't take the square root of a negative. Capiche? So, this one is symmetrical around the oblique asymptote. So you can draw an oblique asymptote right here. And you see that the black is the original function. And the red is the inverse function. And what do you notice about the red and the black right here in the first quadrant? It's symmetrical around the what? The oblique asymptote. All right? Or a line, the axis at 45-degree angle. You see that? Mm-hmm. That's what the inverse function is. All right? The inverse function, I give you, let's erase this. And let's say I give you, we'll go over plenty of them, don't worry. Let's say I give you y f of x is equal to x cubed. Well, what's the parent graph look like with x cubed? It looks like the what? The s, right? Or the curve. Everybody agree with that?
yes, sir.
So now I'm going to do f of x, y is equal to x cubed. And then x is equal to y cubed. And then y is equal to the cube root of what? X. And then if you graph that, you're going to get the function that looks like this, and it's going to be symmetrical with this right here. I can't remember what it looks like. We'll draw it on a graph calculator in just a minute. You could actually x, y, -2, -1, 0, 1, and 2. What is the cube root of -2? Well, it's going to be negative what? Something small, right? Somebody take 2 and raise it to the 1/3 power. What do you get? Make sure you put the 1/3 in parentheses. What do you get? 2 to the 1/3 power. What do you get? Come on, some of y'all on the calculator drill team, y'all can twirl them things around on your finger like a basketball. What's the weight? Come on, let's go.
1.26.
Okay, 1.26. Okay, I'll do this one for you. Cube root of -1 is -1. Cube root of 0 is what? 0. 1 and 1.26. So graph those, and we'll do that in rouge. So -2, 1.26. -2, 1.26. I'm exaggerating a little bit. -1, +1. And 0, 0. And then, of course, 1, 1 be like this. And then 2, it would be like this. Yeah, that's what I thought it was going to look like. Again, what do you see in the first quadrant? You see a symmetrical around the oblique right here. Okay? Now, not all are going to be like you saw in the first example, but you will see some symmetry around usually the first quadrant. All right? Now, at the top, you see in this slide, it talks about one-to-one function. One-to-one can be seen with what's called the horizontal line test. The vertical line test, y'all remember that? That was to tell if a function is a what? A function. I don't know how to spell vertical. Is that vertical? Vertical?
Nope.
Vertical line test is a see if something is a function. Okay, vertical line, we'll do it in blue. Is it a function? Yes, because it only has one what? Intersection. So that was the vertical line test. The horizontal line test means that it is a what? A one-to-one function. So if you have a function and you draw a horizontal line through it, is this a one-to-one function? Yes. If it crosses 2 times or 3 times or 4 times, then it's not a one-to-one function. So write that down. One intersection means a one-to-one function. Now, what do you have to be careful of with higher functions? You have to be careful of hidden what? Hidden behavior. I'm going to write that in red. You got to look out for hidden behavior. Hidden behavior would be something like this. You have a x to the 5th function or x to the 7th function. What happens here? Horizontal line test tells you what? It is not a one-to-one. So you got to be careful, and you got to know how to use your calculator to find the hidden behavior. The hidden behavior usually is going to be in the saddle, remember? I don't remember if I told you or the 109 this. Have I told y'all that? Yeah. The saddle, that's where the hidden behavior is going to be. So you got to use your calculator and not trust what your eyeballs tell you. You got to zoom in, especially if it's an x to the 3rd, x to the 5th, x to the 7th, or an x to the 8th, because x to the 8th might have an x to the 3rd in there, and then that would make it have that saddle. So you got to do it with the higher functions. Okay? Got to watch it, the hidden behavior. Okay? So that's what one-to-one means. One-to-one means that for each x, you get one what? For each x, you get one what? Y. For this x, okay, or there's several y's here, and that's what it's getting into. One-to-one means one x, one y. And we'll get to the ones that are not in just a minute. Okay? So, what does let's turn this around because you never write it like this. So f of x is equal to the square root of negative x squared plus 25. You would graph that. You know it's a square root function. The negative x squared plus 25 is equal to what? 0. Negative x squared is equal to negative what? 25. Divide by negative 1. Divide by negative 1. X squared is equal to 25. And what is my x? What can my x not equal? A 5 or what? Negative 5, right? So let's plug them in. 5 squared will give you 0. Negative 5 squared will give you 0. So let's check and see what numbers will give you a negative. Because you can't take the square root of what? A negative. So let's draw our number line. And y'all should know how to do this because it's just common sense. Negative 5, positive 5. All right, what's below negative 5? Give me a number. Give me a number below negative 5.
Negative 2,500.
Negative 6.
Negative 6, thank you. Plug in negative 6. Okay? Well, I got a negative there. Negative 6 times negative 6 is 36, but it's got a negative in front of it. Negative 36 plus 25 is a what? It's a negative. So can I use these numbers?
No.
No. So you take your red marker and you draw an X right there. All right, give me a number between negative 5 and 0.
Negative 30.
Negative 1, the easiest to use. Negative 1 squared is 1. Negative 1 plus 25 is positive or negative? So we can use those numbers. So it gets a green check.
Yay.
And we can use 1. That's going to be what? Positive. So we can use these. Check. And 6. What's 6 squared? 36. Negative 36 plus, can't use these. So that means that our domain is affected. We can only use numbers between negative 5 and what? So your function is only going to exist between negative 5 and positive 5. So whatever the function looks like,
It's going to get cut off.
it's going to get cut off. Good job. You're making the connection. Good. You're the one. I'm sorry. So here we go. We know whatever this function looks like, we know a square root function looks like what? Looks like this, right? Because you know your family of graphs, because you learned them. Okay? Raising that bar. So negative 5 is here. Negative 5. And positive 5 is here. So this function is going to be, if you take the square of these numbers, that's 5, so it's going to have a vertical shift of 5 to the left, right? So that'd be right here. So your function is going to look like this, except you're going to erase it where? Well, one of these days. Here we go. And it gets a dot there and gets a what? A dot there. Or whatever the case may be. Okay? Question, gripe, complaint. It should get a 0. You'll have to graph it. You'll have to graph it to see what it looks like. But the main thing is you see that it what? It's going to stop. Now, I think it's going to go like a dome.
Yeah.
It does?
Yeah.
Okay. So, I'm not thinking out that loud. Hold on. So it's going to go like this. Now the first thing I need to ask you, is this a one-to-one function? Good job. No. Why? Because your vertical line test tells you what? It crosses what? Twice. So it is not a function. I mean, not a one-to-one function. It is a function because the vertical line test tells us what? It's a function, but it's not a one-to-one function. So you feel good about yourself.
Yay.
All right, now y'all do that one. That one's pretty simple. What kind of line is it? A straight line. So chances are it's going to be a one-to-one function no matter what you do. Why? Because it's only going to cross the vertical line test once and the horizontal line test once. So we know that this one is what? Now you see why you need to know your family of graphs and why you need to know the vertical and the horizontal shifts and things like that? Yes. That's why. Y'all learning so much. You're welcome. Y'all might be able to work at Chick-fil-A for long. What? That's a pretty good place to work. I don't know why. Everybody I talk to, except for you, says it's a good place to work. You're Russian, aren't you? No, you're German, right? Why do you hate that place so much? Or not hate it. Why do you dislike it?
They do not really work with them.
They what?
They don't really work with their employees.
They don't work with them?
I've spent 5-6 hours outside.
Outside?
I've
Well, that's because they're so busy. I think they need to do something different there, like maybe put a little booth out there.
had. You get food.
Yeah.
Employees have stuff.
But who's the most important? The customers are most important. I mean, no matter where you go in retail, who's always right? Customer. Customer is the number one, because you don't have a customer, you don't have a what? You don't have a job. That's why I bear with all y'all students, even though I hate all of y'all. That's why I'm so nice to y'all, because y'all pay my paycheck, okay? Except for Pendleton, I don't like them.
That was an arrow through the heart right there.
Oh yeah.
Thought we were friends.
Pendleton, are y'all paying attention or what?
Yes, sir.
Okay. Oh, there's the other one. He finally came in like 15 minutes late. All right. Look, so what do we got? The first one is not a what? One-to-one. I bet the second one is. It's a miracle. And they also plugged in, they said f of A is equal to f of B. What are they doing? They're plugging in. Okay, what are they doing? Let me show you. And let me erase mine. Now this is the way you can do it algebraically. Okay, we choose A is equal to 3 and B is equal to negative 3. I didn't choose negative 3. I chose what? I chose negative 6 and what? Positive 6. And they both gave me a what? A negative. So I knew I couldn't use those numbers. So that's why, so I don't care how you do it. You do it however you want to. But the reason I did what I did is because that is what you're going to be using later to find your real zeros, what works on the number line, and you're going to be doing that later. So that's why I just did it that way. Kill two birds with one stone for later. Here you can plug in whatever you want to. You know, I just think the horizontal line test is a whole lot quicker. Okay, look at there. There's a vertical line test. I'm sorry, the horizontal line test. And again, you've got to watch out for hidden what? Behavior. You've got to watch out for the saddle. What kind of questions will this be on the test? Out of 10, probably 1 or 2 with the horizontal line test. So everybody should get them right. If you don't what? You don't tell anybody. Okay? So make sure you know the horizontal line test. Pretty simple. Okay? All right, there's the x cubed minus 1, and there's the square root, cube root. So let's do the inverses. Let's do it algebraically. So I'm going to let y'all do the inverses, and then we'll do it together. F of x is equal to x cubed minus 1, and g of x is equal to cube root of x plus 1. So go ahead and do those two. And first of all, you got to drop the pinky and make f of x equal y. You're back in pre-algebra days. And then exchange the y and the x and solve for solve for y. Y'all should be able to do those without any problem. Because you already put it algebra now. And 90% of doing good in calculus is doing good in what? Algebra. Oh, is that the thing? Oh, that's people still in high school. You park in a certain section and the trucks, they all park side by side because they look alike. We still doing that? And then you sit back and look at your truck. Girls, run as fast as you can when you see somebody do that.
I would feel it.
Mr. Hubert, do you teach math 125?
I teach 120, yes. The one, I don't know which one I'm teaching yet. It's going to be the 8 or the 10 or the afternoon. That's all I know. She hadn't assigned me yet.
Okay.
So just wait. And I'm also teaching the 130, which is business calculus, which is a good preceding class for calculus. You might want to take
What time
it.
is that?
Huh?
What time is the 1:30?
It's taught here, so just it's the only one that's at the Anderson campus. It's in this room. It's college. So 130, I'm teaching 120, and I'm teaching 103. Those are the only ones that y'all be interested in. But the 130 is a good preceding class. It's college transferable. It will transfer in the non-science engineerings as well as the ag engineering, business, marketing, and it is business calculus is what it is. You can use it as an elective and you can use it as a preceding class for the 110 or the 140. I usually teach the 140 in the summer. So, you might need to take trig before you take that 140. So, I'm not teaching 111 next semester, so that means somebody else is. I don't know if I'd take that if I was y'all. Yes?
Can we take 130 in the spring?
You still have to take 111. But I would suggest I may be teaching 111 in the summer. I may. I don't know. But I know I'll be teaching it in the fall because I'm teaching it. Is this fall? Yeah, I'm teaching it I teach it every fall. So you could take the spring, you could take 130, and then you could take the 111 in the fall, and then you could take the 140. Now, that would be for somebody that is real scared of calculus, because that'll give you a warm-up. Because business calculus is calculus without the trig. Okay? And then you would take the trig, and then you would put the two together, and you'd be ready for 140. So, it's a good class. It just doesn't have trig in it. All right, here we go. So I'm going to exchange and call this x is equal to y cubed minus 1, add 1, and take the what? Cube root. And basically that, I didn't read the question. They want to say, oh, is g the inverse function? Yes, it is. Because if you was to do this one, x is equal to the cube root of y plus 1, then take x cubed, and that's going to be x cubed is equal to y plus 1, and then x cubed minus 1 is equal to y inverse. That should be this one over here. So you see that they're inverses of each other. If you graph them, you will see that they will cross each other and there will be a symmetry there. Okay? That's a good test question. I'm going to ask you to graph and algebraically do the inverses. So make sure you can do them on your calculator.
So a -1 on the y, so the inverse function.
Yeah, you would write it. Oops, that's supposed to be a negative right there. -1. Yeah, y to the -1 is called the inverse function.
Okay.
And there's the function, and you'll see the next function. You don't have to graph it on your calculator. Well, they didn't graph it. I thought they would. There's x cubed minus 1. The other one is going to look like this. I don't know why they didn't show it, though. So if I was to draw it, it would look, if I can try it, it would cross right here. Kind of like that.
Yeah.
Is that what it looks like? So make sure you can graph both of them on your calculator. And you're looking for that symmetry along the 45-degree angle. Usually that's what it is. And of course, is this a one-to-one function? Yes. But again, you got to be careful here. Okay? All right, they want us to do G composed of F and F composed of G, so just
Your pinkies out.
give me, we got to get our pinkies out. So let's go ahead and write, what was F of X? F of X is equal to what?
X cubed minus 1.
X cubed minus 1, and G of X is what?
Cube root of X plus 1.
Cube root of X plus 1. So when I do fog, that means I'm going to rewrite F with a big set of what? Parentheses. So I'm going to do equal F composed of G. I'm going to rewrite with a big set of parentheses, and I'm going to plug what into those parentheses? G, cube root of X plus 1. And of course, what happens to the cube root and they go out. And that's going to leave X, I think.
Yeah.
So F composed of G is equal to X plus 1 minus 1. The minus 1's cancel, and you're left with X. Now let's do Goff. Goff means that I'm going to rewrite G with a big set of what? With a big set of parentheses. Cube root, parentheses, plus 1. And then I'm going to plug in what?
Ah.
I'm going to plug in
X cubed.
X cubed minus 1.
And then the ones cancel.
And yes, well, yeah. And then that'll leave X.
So
And-
the inverse is always just equal X.
What?
When
If it's the inverse, it'll always give you X. Oh, I need to sit down. I'm not used to critical thinking. I'm not used to it. Usually I have to beat y'all over the head with a 2x4 to get y'all to understand this. Not y'all, other students, you know. No, Pendleton usually is pretty good. They just don't talk. They're just introverts. And there we go. And there you go. Okay? So if they're inverses of each other, if you compose them of each other, you should get the same X.
Whoa.
This, I don't like to use those clouds because that confuses people, so we're not going to use them.
potato.
Okay, I'm not going to use those. Not going to use those because that changes. Okay, what are we doing here? Algebraically finding the inverse. Interchange, solve, replace with f of negative 1. We already done that.
Yay.
So y'all should be able to find that one. Change it. Y is equal to 2x, which will be x is equal to 2y plus 5. And minus, that'd be x minus 5 divided by 2. And that is the inverse function. So we already got 2 or 3 questions out of this unit, out of this section. 1, be able to graph the inverse. 2, make sure you can algebraically find the inverse. And 3, make sure you can do the horizontal line test to see if it's a one-to-one function.
Okay.
And there, make sure you do that f of negative 1. There are some teachers, you know, with those things that y'all do in class, what are they called? That you sit in class and you take a test. Yeah, you sit in class and you draw on a piece of paper. There are some of those. Yeah, there are some of those T-Rexes still around. And you have to put that f to the -1 penalty, and if you don't, they'll mark the question wrong. So those of you that get some of those T-Rexes, you know. All right, what will this one be? This is a test question. And I will give you more algebraic than I will give you graphing. So if I give you 2 graphing, I'm going to give you 5 algebraics. So you're going to have more algebraics. That way I can discourage you. So y, drop the pinky, exchange. So that's going to be x is equal to y squared plus 2. X minus 2 is equal to y squared. Square root of x minus 2 is equal to y to the -1. And of course you could write f to the -1 of x if you wanted to.
No, I like this. -1.
Yeah, why mess it up?
Yep.
Is that it? I can't remember what we just do. Did we just get that, or are they doing it right there? Okay. Is that what? That's not what we got, did we? Wait a minute. No, that's a different question.
Oh, I'm about to say.
Okay, I guess they're doing this one. Yeah. So take the cube root of x. After you take the cube root of x, then you're going to have the cube root of x is equal to y minus 2, and then you're going to bring y plus 2 over, and that's going to give you y is equal. And don't forget what? Y to the -1. And there's your pinky. Bring your pinky back. F to the -1 of x. Or y to the what? Y to the -1.
I like that.
Okay? And here's an example of the inverse of a line. What does the inverse of a linear always cause at the intersection? 90-degree angle, perpendicular, always. Okay, this is the graph of f of x, graph f of -x. Well, f of -x, what did I tell you? It's going to go probably right here, and it's probably going to cross right in there. So you can't graph them because that looks like the square root of x minus what? 2? It would be plus 2, wouldn't it? Yeah. Square root of x plus 2. So if that was the square root of x plus 2, is 15-minute class over with?
Yeah.
Yep.
What time is it?
You got 2 minutes.
I got how much?
2.
2. Square root of x plus 2, that's what that looks like, because it's got a horizontal shift of what? 2 to the left, so that would be x plus 2. So x is equal to square root of y plus 2. Square both, so that'd be x squared plus what? Minus what? 2, which means a vertical shift of what? 2 down. 1, 2. And you could find your vertex, but it looks like to me, if you set these two equal to each other, square root of x plus 2 is equal to x squared minus 2. If you set these two equal to each other, square both sides, that's going to be x plus 2 is equal to x to the 4th minus 2 be 4x squared plus 4. Bring this over, and that's going to be, and bring this over here. 0 is equal to x to the 4th minus 4x squared minus x. What's 4 minus 2? Plus 2. And solve that, you get basically that they're crossing like that. Something like that. You'd have to do it on the calculator.
Something like
So make sure, if you're given a function, not only can you sketch it now, but you can sketch it, you can check it with a horizontal line test, and you can tell me algebraically what the inverse is. And that is basically, in 109, it's 5.1, and 110 is 6.1. So you should be able to start working on what? There we go. There it is. Okay? And make sure you can graph it on your what? Your calculator. Y'all get out of here and have a good day. See y'all then. Friday for another